The video just stopped for some reason and I was still doing a whole lot of talking. Okay, so it stopped over here. So we just add the like terms. So 1.5 plus 1 is 2.5. The 3 minus the 1 is 2. And then to get rid of these fractions that has a denominator of 2, I can multiply right through by 2. So if I multiply that by 2, that gives me x squared. 2.5 times 2 is 5. 2 times 2 is 4. Factorize that. It's going to give me x plus 4, x plus 1. Solve for x. X will be negative 4, negative 1. So now I have the x values. I must still find the y values. So I can go back and substitute it into either one of these equations. This one is the simplest one. So if I substitute the values for x in here, that should give me if I substitute negative 4 in there, the answer is negative 2. Substitute negative 1 in there, answer is negative half. Okay, so my two coordinates is negative 4, negative 2, negative 1, negative half. Now we need to see which goes with what. Né? So negative 4, negative 2 would be these coordinates. Né? We can see there's negative 3. So negative 4, negative 2 has to be these coordinates. So let's label that. So that would be D and that one would be C. Right, 4.6. So they say, use the graphs to obtain the solution to where 1 over x plus 3 is greater and equal to x plus 2 over 2. Okay, so I wanna go back to the original equations. 1 over x plus 3 minus 1, and the other one was half x. Yeah? That was the original equations. And now what are they giving us? They're giving us 1 over x plus 3 is greater and equal to x plus 2 over 2. So I just want to see how does this differ from this. Né? Let us quickly simplify this a bit. So that's 1 over x plus 3. So that would be x over 2 can be written as a half x plus 2 divided by 2 is 1. So let's look at the difference between that and that. So can we see that we basically, to go from here, or from here, sorry, to here, we added 1. So if I add 1 to this negative 1 falls away, right? Giving me this. If I add 1 to this, gives me this. So what has happened is, if I add 1, it means if I add 1 to both equations, it means both graphs shift 1 unit up. Né? So it doesn't shift left or right, it just shifts 1 unit up. So another graph is asking, where is this greater and equal, where's this greater and equal than this? So it doesn't really affect the graph because everything is just shifted 1 unit upwards. So I can just look at the graph as is. So what they're basically asking me is, where is the hyperbola greater and equal to the straight line? And for hyperbolas, we need to look at each quadrant. So let's start in this quadrant. Where is the hyperbola greater than the straight line? So it would be this portion over here. So I need to know what is that x value, and we know what that x value is. That x value is negative 4. So my first answer is x is everything less and equal to negative 4. Or now we go to the other quadrant, and where's the hyperbola greater? This portion over here. No? So, and what is this x value? That is negative, no. That is negative 1. Negative 1. Okay. And it goes this way, but it's not going to touch the asymptote at -3. So I can say x is greater and equal to, no, not equal to, because it's an asymptote, right? It never touches there. Greater than -3, but less and equal to -1. And those are my answers for 4.6.